Good afternoon, everyone. In this tutorial, we're going to learn some of the basics of R and hopefully get a little bit more comfortable working in RStudio. So, like I mentioned last time, RStudio is broken up into 4 panes. 2 of these panes are our workspace. So down here, we have the console. Anything we write in the console will be executed as soon as we hit enter. Up here, we have the source pane. Anything you write in the source pane won't be executed until you click run. This is also where you can write anything you want to save, and it's also where if you open a saved script file, this is where it will appear. So anything you want to keep for later, you probably want to do up in the source pane. Anything you just want to do right now, you can probably do down in the console. Before we get started, let me go ahead and zoom in a little bit, hopefully, so it's easier for you guys to see. Okay, hopefully that's better. So we have 3 main topics to cover today. We're going to talk about basic math operations, we're going to talk about variables, and we're going to talk about vectors. So first we'll start with the basic math operations. So just like you're probably used to, we can do simple math within R. So if I type 5 plus 6 and I hit enter, we get an output of 11. If we're not limited to integers, I can do 1.2 times 2 and we'll get an output of 2.4. We can also string together operations. So if I do 6 plus 7 times 2, we'll get an output of 20. That's because R does respect the order of operations. So the multiplication happened first, then the addition. Just like you're probably used to, we can control this using parentheses. So in parentheses, I can put 6 plus 7 and then multiply by 2, and we'll get an output of 26. The other operations we have access to are division. So if I do 22 over 11, we'll get 2. And one that you might not be familiar with, we have a function called modulus. You get to it using 2 percent signs. So if I do 22 modulus 10, we'll get an output of 2. So the 2 is the remainder of a division. So 10 goes into 22 twice, and you have 2 left over. That's where that comes from. So those are our basic sort of mathematical operations we have access to. To make more use of it, though, we can get to our second topic, which is variables. So using variables, we can store certain values. So our syntax for creating a variable and assigning it a value is a little bit weird compared to most languages, but let's do it here. We'll create a variable called n. To assign it a value, we use the syntax less than dash. You'll notice it looks like an arrow pointing at the n. And we'll give n a value of 15. When I hit enter, you'll notice up here in our environment tab, we have an object created. It is n, it has a value of 15. Now down here, if I input n, it returns the value, 15. I can also use this variable in operations. So if I do n times 3, we'll get an output of 45. If you want to overwrite the value of a variable, you can do that just the same way you gave it a variable in the first place. So let's change its value to 19. And then if I put in n, it outputs its new value, 19. The 15 is gone. It's been overwritten. We don't just have to create numeric variables. We can also create text variables. So let's go ahead and create y. And y will be a string. We'll just give it sample text. Now if I input y, we'll get the output of sample text. If you want to check what type of variable you have without outputting its value, you can use the function class. So the class of n is numeric. N is a numeric variable. The class of y is character. It's a string, right? If you don't just want to overwrite the value of a variable, but you want to get rid of it completely, you can use the function rm for remove. So let's go ahead and remove y. And you'll notice y is no longer in our environment. If I input y, object y not found. Another important thing, the names of variables are case sensitive. So if I input n, we get 19, but if I input capital N, error object capital N is not found because capital N is a different thing than lowercase n. So like I said, we can use a variable within our math operations, right? So n times 3, output 57. And we can also use operations to assign values to a variable. So if I want m to be equal to n plus 5, I can do that. Now I've created m, and it is a value of 24. It's 5 more than n. Now it's not going to remain n plus 5. Notice it's just been assigned a value of 24, not specifically n plus 5. So if I change n, these are self-referential, by the way. I can do n is n plus 1, and now n is 20. But do note that did not change m. M doesn't remember that it got its 24 by being n plus 5. It just has a value of 24. So I can change n, and it does not retroactively change m. And yeah, we can do these self-referentially to change the value of a variable based on its own value. So you can iterate things in that way. I think that's all we want to get to for variables. Okay, so other than variables, we can do a little bit more if we create lists of values. In R, these are called vectors. In other languages, you may have heard them called sets. So if I want to create a list of values, we use a very similar syntax. Let's actually jump up here to the source pane, and I'll start by writing a comment. To write a comment, we start with the # or hashtag, depending on what you want to call it, and then anything we write on that line will be interpreted as a comment, not as script to be run. So I can write whatever I want here, and it's not going to cause any errors. So let's say maybe I'm running a gym class, and I am recording jump heights. So we're going to record how high people can jump. And we'll do this in a vector. So I'll call this vector jump, and I'm going to assign it a value, just like we did with a variable. But since I'm giving it several values, not just one, I need to use the function c. C is for combine. So anything I put in this is going to be a list combined into the vector jump. So let's go ahead and give it a list of values. We'll say 12, 16, and 20. Oh, you'll notice now that we're working up here in the source panel, hitting enter did not run anything. If I want to run it, I need to click the run button. So now you'll see the comment was pasted to the console, then the script that we ran was pasted to the console, and run. So up here you can see we created an object. It is jump. It is a vector with 3 values, 12, 16, and 20. This here is telling us these values are indexed 1 through 3. The cool thing about that is the values are indexed, which means we can refer to them. If I want to refer to, we'll come back here down to the console. If I want to refer to just the second value in jump, I can do jump, and then in brackets I can put a 2, and that's going to return me just the second value in jump. If I just put in jump, it'll give me the whole vector. But you could have very, very long vectors. Maybe you don't want all of that. If I do jump 2:3, it's going to give me the second and third values in jump. So in this way, we can refer to particular values within our vector. We can also use the same syntax to overwrite a value within our vector. So maybe as I'm doing this, I realize, oops, that third one was a typo. It was supposed to be 22, not 20. So to fix that, I could do jump 3. That says I'm referring to the third value in jump, and I want to assign that a value of 22. So now jump has been changed. It now has the values 12, 16, and 22. Right? We can also use the C syntax to add values to a vector. So let's say I have jump, and I want to add more values to it. So I'm going to create a list, and I'll start with the list that was already in jump, but then I want to add more values. Maybe we get a 14 and a 10. When I run that, you'll see jump still has the 3 values it had previously, and it was combined with the 14 and the 10. So those were added to the list. The values are now 1 through 5. We can also use variables for this. So I can add, let's do jump, and again, we'll combine the list of jump, its current list, and I will add n and m, the variables that we created earlier. And while we run that, now we can see jump has all the previous values, and we've added the 2 from our variables. Now, just like m didn't change when we changed n, if we change m or n, it's not going to change jump. So let's go ahead and change n to be 3. Now n is 3, but jump has not changed. Where n is still 20, right? So just because you use a variable to create a vector, changing that variable doesn't retroactively change the vector. The vector just, when you write that, it assigns it those values. There's some other really cool things we can do with vectors. So we talked about how we could refer to a particular value within the vector. If I want just the 5th value in that list, I can do 5 in brackets, and it'll give me just the 5th one. If I want to add values, we saw how we can do that with the C, combine the lists. If I want to do math using all the values in a vector, we can do that too. So if I do jump divided by 2, we're going to get all of these values divided by 2. Oh, we happen to have all even values. I was expecting a decimal. It will return decimals. That's not a problem. Let's do jump divided by 3 just to show that. Okay, so we can do math using all the values within a vector very efficiently. That's pretty cool. We could also do something like, let's say, we want to set everyone a goal to increase their jump height by 2 inches. So I could do goal and assign it the values of jump plus 3. So now goal has been created as a vector, and each value has been increased by 3. We can also use a vector to do different aggregate functions. So let's say I want the total of jump. That would be sum. So the sum of jump is 118. If I want the average, the function for that is mean. So our average jump is 16.8. And if I do range, this may not do quite what you're expecting. It's not going to do the highest minus the lowest. It's going to return us the highest value and the lowest value. So our lowest value in jump was 10. Our highest is 24.